Now let's say we're given x is equal to u squared minus v squared, y is equal to u squared plus v squared. What would the Jacobian of this look like? So what would this first term be if we were to find the Jacobian of this set of equations? We're doing it in terms of x and y. So you don't need to prime it. Any ideas? So for this one, it would be the partial derivative of x in terms of what? It could be u. It could be u or v, it doesn't really matter. So let's say u. So then what would that look like?
2u or 2a.
It would just be 2u. So we're just finding the partial derivative of this, x in terms of u, and then it's just going to be 2u, and it's going to be 0 because there's no u term with that v squared, okay? Now, what about this part? What's this going to be? dx dv, yeah, so what would that be? Yeah, negative 3. And then this is the same term for y as x, so this would just be 2u. And that's just going to be 2. So pretty straightforward with the Jacobian. Now let's do a different problem where it's a little more complicated. So in the lab that we did last week, when you guys plugged in, or when you guys had the Jacobian, right? You have to plug in your points, right? You have to plug in your equilibrium point to see what it leads up to. That's the same thing we're going to do here. We're just going to say, we're going to find a Jacobian in terms of each of those points. So our Jacobian was what? Where's the Jacobian? Oh, actually we don't make it. So let's make our Jacobian. Let's say j is equal to this. What is this term going to be? I'm going to write this out. It's easiest. What's our Jacobian? So for this term, we're looking at x prime in terms of x, right? So that's just going to be 1 minus 2x minus 2y. 1 minus 2x minus 2y, right? You guys all know how I got that. Okay, so now the second part is going to be in terms of y. We only have one y term, so everything else is going to go to 0. So we could just say minus 2x for this one. Okay? Now for y prime in terms of x, it's going to be minus 2, right? And what would it be for y in terms of y? Okay. So 1 minus 2x minus 2y, and that's your Jacobian. So now to find the stability of each of those points, we have to plug these guys in to here. So I'm just going to do one example, so we don't have to do the rest. I'll just say j of 0, 0 is equal to, we plug in 0 for x and y here, we end up with 1, did I forget y? Yeah, maybe 2y, or x. This would be 0, this would be 0, and this would be 1. Lambda plus 1, lambda plus 1, which means it's going to be lambda minus 1, and lambda is equal to negative 1, and lambda is equal to negative 1. So since they're both negative, they're also unstable. So actually, I think this part is stable. I think I looked at the wrong answer choice. This is unstable. So these are our actual eigenvalues. Okay, good catch. But yeah, that's it.